Howdy! Welcome to Aspire Mountain Academy. I'm Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video explains how to construct confidence intervals for population means using an old school approach. Let's get started. So, in an earlier mini lecture, we talked about how the key question you need to ask when constructing a confidence interval on a population mean is, do we know what the population standard deviation is? Typically, the answer to that question is going to be no, in which case we want to use a student t distribution to calculate our critical value. So, when we don't know what the population mean is, we can use that t distribution to construct our confidence interval. So here's the general form for a confidence interval, where x bar represents our sample mean and e represents our margin of error. Of course, mu is the population mean. So we're going to do the same general process that we did for proportions. We're going to do that same sort of thing here when calculating confidence intervals for the means. But there's some minor modifications we need to be aware of. First of all, we've got a slightly different equation for calculating our margin of error. And because we're using the student t distribution, we have to take care to recognize degrees of freedom, which of course is 1 less than the sample size. Our critical value t sub alpha over 2 and the corresponding t-scores are calculated using either a table or software. We'll look specifically at that point in the next mini lecture. And then with either tables or the software, we're going to use n-1 degrees of freedom in order to calculate the critical value that we need to calculate the margin of error. So the way we construct this is pretty much like we did before with proportions. First, we verify required assumptions are satisfied. The sample must be a simple random sample. The population is normally distributed. If it's not normally distributed, then of course we've got central limit theorem coming in. If our sample size is greater than 30, we can say that we're approximating a normal distribution. And then the next step is to find the critical value t-score that corresponds to our desired confidence level and n-1 degrees of freedom. With that, we can then calculate the margin of error. Once we have the margin of error, we can then find the values for our upper and lower limits for our confidence interval and place them in whichever format that we need to for our confidence interval. We're going to round the resulting confidence interval limits to 3 significant digits. Just as we saw with proportions, this is a standard typical convention. Now, in the other event where we actually do know what the population standard deviation is, then we're going to use the standard normal distribution to construct a confidence interval. This one always had me kind of scratching my head, because why are we making an estimate on the population mean if we know what the population standard deviation is? Typically, if you know what the population standard deviation is, you also know what the mean is. So why are we trying to estimate what we already probably know? That never made much sense to me, but once in a while you get a problem thrown at you where they say, here's what the population standard deviation is, and so you have to use the standard normal distribution to calculate your critical value. Again, our confidence interval is going to take a similar format to what we saw previously. The minor modification that we have in this instance is that, again, our slightly different equation there for margin of error. Instead of a t-score, we've got a z-score. The critical values, as we've seen previously, can be calculated either with a table or software. And that brings us to the end of this mini lecture. I hope you found it helpful. You can find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.